So good afternoon. My name is Bronwyn Wilson, and I'm the director of the Clark Library and the Center for 17th and 18th Century Studies. It's wonderful for you to be here today, and we're especially pleased to be recording the lecture and the discussion today with my fantastic colleague, Thiago Puglieri. Before we begin, I just wanted to acknowledge the Gabrielino Tonga peoples as the traditional land caretakers of Tovangar, the Los Angeles Basin. As a land-grant institution, UCLA pays our respects to the Hanukvetam, the Ahiram, and the Evuhinkam as relatives past, present, and emerging. I also wanted to thank all of the people who've been, and I probably won't be able to thank everyone who was involved in helping to organize this, but Jeanette Levere, Jean Schneidevend, Becky Marshall, Eric Ulrama, Alejandro Sanchez Nunez, Ikumi Krokel, Becky Marshall, Derek Quesada, and my thanks to the team. So now a few words about Thiago. So Thiago joined the Department of Art History 3 years ago, and it's just been wonderful to have him in the department that I also teach in. He's a professor of technical art history, conservation science, and indigenous cultural heritage. Thiago's teaching and research are located at the intersections of art history, chemistry, and conservation. His interests are in technical art history, conservation, and science, focusing on indigenous cultural heritage from the Americas. His projects delve into historical and cultural aspects while also exploring scientific and technological advancements within indigenous cultures. The investigations involve archival research, chemical characterizations, and engagement with indigenous communities through community-engaged research. He teaches and supervises students in the Department of Art History and also the UCLA Getty interdepartmental program in the conservation of cultural heritage, and that's something with the Getty Villa. He's been involved in many different projects. Prior to joining our department, he was professor at the Department of Museology, Conservation, and Restoration of the Federal University of Pelotas in Brazil, teaching and advising students in the graduate program on social memory and cultural heritage. He has also worked for the Netherlands Institute for Conservation, Art, and Science, and he was vice president of the National Association of Research in Heritage Science and Technology in Brazil, as well as the Brazilian Association of Non-Destructive Testing and Inspection. And I think that's one of the things I've come to appreciate so much about Thiago's work, is to think about the ways in which we can have an ethical relationship to objects that we're conserving through technologies of science. And it's something that you'll have a chance to see this after the presentation, and also Thiago will give his talk, and then there'll be questions, a period of questions and responses, and then he'll do a demonstration for us as well. So we're delighted to have you here for that, and Thiago, welcome.
Thank you so much, Bronwyn, for the introduction. Thank you all also for being here today, and also for the others that are on YouTube. It's an honor and pleasure to be the speaker of this third annual Spotlight Talk series at the Clark Library. And I would like to thank all the organizers and the amazing Clark Library staff for helping with everything in here. This talk is being presented in Los Angeles, which is part of the unceded land of the Chumash and Tongva Gabrielino people. I would like to acknowledge these communities and pay my respect to their past, present, and future elders. Today, we will explore a perspective on cultural heritage you may not have considered before. It is the view from the chemistry lab inside art history, cultural heritage, intercultural education, and community engagement. So cultural heritage is vast. It's tangible and intangible, covering everything from artistic and historical works to religious and sacred items. Its impact is far-reaching it touches our well-being, the environment, the economy, and politics. Because the nature of heritage is so diverse, the research must be diverse too. This is why scholars from the humanities and sciences work together, complementing each other's experience and expertise. Today, we focus on the critical role of chemistry in understanding and preserving our past, and in doing so, improving our future. This presentation also complements the other excellent talks we have had here at the Clark Library, including the last one in which Dr. Johanna Drucker addressed, among other topics, the erasure of indigenous people in Western landscape painting. Now, let's turn our attention to some objects from the Clark collection. I want to start showing you a few items we have selected from the Clark, which are displayed here in front of us tonight. So in this slide, from the left to the right, we have first a carved gunpowder flask made from a hollow gourd sealed with a metal-capped cork stopper. Next, a metal trunk from Morehouse Archive. This trunk housed correspondence from the Hopi family and is a container, as a container, it holds significant meaning for understanding their collecting practices between the 1890s and the late 1990s. We also have a delicate portrait miniature with mica overlays and a fishing hook and handle-plied line. We selected these specific items because they demonstrate a variety of materials that chemists may encounter and are suitable for the demonstration we will have after the talk. You can see materials like organic fibers, gourd, metals, paint, and varnish. Oops. Many other examples and materials variety are evidenced in this building. If we have a look around, we will see these colorful Eric Gill watercolors, which are also exhibited here today in front of us. In addition to paintings, books, documents, drawings, sculptures, furniture, architectural materials, and so on. But despite their differences, all these items share a common thread. They are utilitarian, decorative, historical, and sentimental objects that played a role in someone's life. But how does chemistry apply to cultural heritage and arts and to objects like these? Tangible cultural heritage, the physical objects, is made of materials that degrade over time. To slow this process, conservation procedures are required. This includes the application of other materials for cleaning, removal of old treatments, or simply the preventive conservation. Therefore, the chemists work with most threefold. Investigate the composition of cultural materials, understand how these materials degrade due to environmental factors, and develop new materials and methods for their effective conservation. This research happens in interdisciplinary fields known, for instance, as technical art history, conservation science, and heritage science. So what kind of questions do chemists try to answer? They are often tackling issues at the heart of the humanities, social, and physical sciences. It can involve, for example, manufacturing. How was the item made? This reveals the materials and techniques specific to different artists and cultures. It can involve production. How were these materials themselves created? This is what we call reverse chemistry or reverse engineering. It can involve provenance and exchange. When and where was the item produced, and how did it move between people? These help us investigate authenticity and understand social dynamics. And deterioration. How and why has the item degraded? This offers clues about past uses and environmental changes. Our focus today, however, will be in technical art history and the analytical investigation of cultural objects. Chemists use a vast array of analytical and imaging techniques to investigate cultural heritage. We can mostly divide these techniques based on two criteria: invasive versus non-invasive, and destructive versus non-destructive. Invasive simply means that we must remove a sample from the object for analysis. For instance, to study pigments on these watercolors that I have shown, we might use a needle to take a sample so tiny it is almost invisible to the naked eyes. This might be used for analysis like, for example, Raman microscopy. We are passing around a sample I took from a print in my personal collection, and you likely cannot see it without magnification, but it gives you an idea of the minute size we may work with. When we look this needle under a stereo microscope, you can clearly see the presence of yellow particles or samples that can be analyzed with specific techniques. Similarly, to investigate the varnish of this gourd flask from the Clark, we might take a small sample for example, FTIR microscopy, but using a scalpel blade. We are also passing around a sample taken from a varnish from my personal collection for your reference. Sometimes we can also take samples a little bit bigger than these and embed them in resin, sand them, and polish them to prepare cross-sections like these. Cross-sections like these. By exposing all the layers of a painting, for instance, we can investigate the materials present in each layer. We are also passing around 3 embedded samples, and you can see inside the resin. Conversely, non-invasive means we perform the analysis without removing any material from the object. Many techniques can operate non-invasively, and a common one is, or in our field, is portable X-rays fluorescence spectroscopy, or XRF. And this is the instrument you can see right here in front of us for the demonstration. Another common non-invasive technique, and more familiar to everyone, is X-rays radiography, similar to medical X-rays we get at the doctor's office. A destructive technique is one that chemically alters or consumes the sample removed or destroys the tiny spot analyzed on the object. Naturally, when we consider the common ethics for the scientific investigation of cultural items, non-invasive and non-destructive methods are preferred, ensuring we preserve the object while gathering data. However, even when considering invasive methods with sampling, ethical considerations and guidelines are necessary. Common ethical considerations and guidelines for sampling are found in key documents such as this European standard or the ethical sampling guidance from ICON, the Institute of Conservation. One document focuses on tangible aspects of sampling. The other acknowledges intangible dimensions like spiritual significance or cultural sensitivity, but it stops short of providing concrete guidance on how and why these should truly inform our research decisions. This gap led to one of my main research questions. Are the common ethics and guidance sufficient for the scientific investigation of indigenous sacred and ceremonial items? To answer this and to better understand the intersection of science and ethics in heritage investigation, we will now travel to the Brazilian Amazon forest. Brazil is a massive country, home to 6 major biomes: the Pampa, Mata Atlântica, Pantanal, Cerrado, Caatinga, and the Amazonia. As you can see in this figure, the Amazonia biome, represented in light green, is the largest. It covers over 49% of the Brazilian territory. Globally, about 60% of this entire rainforest is in Brazil, with the other 40% spread across Peru, Colombia, Ecuador, Bolivia, Suriname, Venezuela, Guyana, and French Guiana. The rainforest itself is a truly vital global ecosystem. It supports a staggering array of biodiversity. It's home to over 10% of the Earth's terrestrial species. It regulates climate, acts as a crucial carbon sink, and it sustains life across the entire South American continent, playing a significant role in stabilizing the Earth's climate. The Brazilian legal Amazon region is home to more than 150 distinct ethnic groups. These showcase an extraordinary level of human, cultural, and artistic richness, with countless cultural items present in museums worldwide. Yet, Amazonian material culture is considered one of the least well-studied globally. In technical art history and conservation science, this gap is stark. Why? One of the reasons is the limited international awareness regarding the richness of materials and techniques used by the Amazonian people. Another is that many scientists face limited access to literature published in Portuguese or Spanish within the social sciences and humanities. To help close this gap, we recently published a paper exploring 70 different materials used for paint production and coloring processes in the Brazilian Amazon, including pigments, dyes, binding media, and varnishes. Historically, physical and chemical investigations of Brazilian indigenous items have focused mostly on inorganic materials like ceramics. This dearth of scientific inquiry into organic materials like dyes and resins has serious consequences. It can hinder our understanding of art history, jeopardize the conservation of existing museum collections, and even threaten the preservation of cultural traditions that haven't been adequately documented or actively practiced and transmitted for many years. Particularly regarding colorants, that includes pigments and dyes, there is another reason for this dearth of scientific inquiry. It is the Western and scientific valorization of materials that are chemically stable and rare. Therefore, shifting these arts from the margins to the center of art history and conservation science and decolonizing the values attributed to these materials are crucial steps. This fosters a more global, inclusive, and decentralized vision of art history, creating a more pluralistic narrative of indigenous art history from South America. This has been my main effort since I was hired at UCLA in 2022. In the Brazilian territory, the Ticuna people, also known as Tucuna or Maguta, occupy 29 distinct lands, represented by gray squares in this map. They live mostly near the borders of Brazil, Peru, and Colombia across all three countries. When it comes to their colorants, the Ticuna utilize almost every possible color prepared from a vast range of natural materials, including seeds, flowers, leaves, roots, barks, and mud. You can see examples in these masks produced for their female initiation rituals. The importance of the paints is such that the masks are said to have no use if they are not painted. Some of the materials they use are well known and shared across many cultures, such as urucum or anato and genipapo. However, this is not always the case, particularly with one of the blue colorants they have been producing. The production of blue has historically presented a significant challenge for different civilizations. Before synthetic colorants, the availability of natural blue hues was constrained by limited resources, mostly certain plants and minerals. Over time, humans learned to synthesize naturally occurring molecules or create novel compounds exemplified by the Maya and Egyptian blues. This scarcity of blues in nature for arts production makes the Ticuna blue particularly intriguing to us, which was unknown in technical art history and conservation science until this research. However, in the Ticuna blue case, specific ethical considerations arise. We can face two main challenges. First, the limited precedent. These masks are ceremonial and sacred items, and currently there are no established specific guidelines for the scientific investigation of indigenous sacred and ceremonial items. This forces us to ask, what are the ethics and responsibilities involved in this kind of investigation? Second, a living discovery. The blue colorant was discovered and is used by a community that is still living and practicing these rituals today. Therefore, the question of ownership and engagement becomes immediate. How can we conduct this research in a way that guarantees respect and mutual benefits for all involved? These two questions has driving our research, and it will be the focus of the remainder of this talk. It's essential for us to acknowledge a critical difference. Indigenous sacred and ceremonial items are not merely objects. They are often viewed as living entities with the power to influence both individuals and the world. These items are crafted from materials imbued with profound spiritual significance. They carry traditional knowledge and personal information often meant to be shared only within specific communities. Therefore, researchers and scientists bear a profound ethical duty to treat these items with utmost care and respect, grounding our work in principles of individual and collective rights and social justice. The most paramount step before any analytical investigation or dissemination of findings is seeking and obtaining informed consent from the relevant indigenous communities and descendants. Sometimes, trained intermediaries such as curators and conservators can facilitate this respectful engagement, allowing scientists to focus on laboratory work without direct community contact. However, in many other cases, direct engagement is essential either because no intermediaries exist or because the scientist's presence in the field is necessary to capture certain material or social aspects. Even when intermediaries are involved, all parties must be aware of the ethical and legal implications of their actions. While community consent may not always be legally mandated, responsible scientists must independently assess whether to participate in projects that disregard these ethical considerations. Additionally, specific legislations regarding the protection of genetic heritage associated with indigenous traditional knowledge must be considered, as in the case of countries like Brazil. In our work, Professor Ellen Perstein and I formalized the proposition of ethical considerations for the scientific investigation of indigenous sacred and ceremonial items in a forthcoming book chapter for 4 different scientific activities. The first is sampling and destructive analysis. So before removing samples or performing destructive analysis, we recommend that researchers and scientists ask permission from the appropriate community representatives and descendants. This is vital because sampling or destructive analysis in these kinds of items can be invasive and destructive in two levels, for their materiality and their intangible dimensions. Therefore, in addition to material integrity, it is imperative to consider the potential spiritual and intangible damages. The second is non-invasive and non-destructive analysis. Even when performing analysis that does not affect the material integrity of the items, we still strongly recommend seeking permission before any experiment. Why? Because even without physically altering the objects, the traditional knowledge embedded in these cultural items may be considered sensitive or confidential within specific groups. The knowledge itself must be respected. The third is publication and dissemination of results. Before publishing or disseminating scientific results, we recommend obtaining further permission, even if initial consent for the investigation was granted. This additional step aims to minimize potential harm, as scientific analysis can sometimes yield unexpected, sensitive findings that may have unforeseen impacts on the communities. Finally, the fourth is uses and impacts of research outcomes. So given the profound spiritual significance of these items, researchers must ensure the project outcomes not only contribute to scholarly and scientific understanding, but also provide tangible mutual benefits to the indigenous community and their descendants. The research must serve to the community, not just the academia. To proceed with our research, all these considerations have been incorporated. So the first study we conducted to initiate and consolidate our relationship with the Ticuna people utilized a more traditional approach from heritage science, primarily engaging the community to obtain consent. Our initial focus was to the investigation of their blue colorants, and it is known from the literature that the Ticuna people traditionally use various plant sources to produce their blues, including bure, anil, native strawberries, genipapo, and the fruit of naiku plant, which is also known as pacova or pacova. The fruit of the naiku plant holds particular significance to us because historical literature suggests it is used in a unique chemical reaction to produce a blue colorant. Courtney Moendaju, a German ethnologist and anthropologist who collected items for both Brazilian and international institutions, described this process in his book, De Tucuna. He noted that the juice of one fleshy fruit, naiku, furnishes a dark violet which, upon contact with iron, changes into a clear blue. This observation strongly suggests the existence of an organometallic blue colorant previously unknown to technical art historians and conservation scientists. This lack of knowledge directly affects our ability to understand and preserve items that contain the blue. To begin addressing this problem, we initiated with chemical analysis of blue colorants present in Ticuna items from museums' collections. We investigated 23 items from the Maguta Museum from the Ticuna community, the Museum of Archaeology and Ethnology from the University of São Paulo, the Peabody Museum of Archaeology and Ethnology from Harvard University, and the Fuller Museum from UCLA. Some of these items are shown here, highlighting their richness in colors beyond blue. We performed sampling on all items and analyzed the colorants using Raman spectroscopy. The results were already published in a scientific journal, and the analysis revealed the presence of indigo, ultramarine, Prussian blue, and phthalocyanin blue in the investigated items. In some cases, we also observed crystal violet, amorphous carbon, and other minor compounds. Although there is no evidence of the blue produced with Naiku, the results indicated that the artists aimed at achieving specific hues by using or combining these different colorants. Moreover, given the profound spiritual significance often associated with materials in indigenous ceremonial items, the selection of particular colorant may hold spiritual meaning. Despite reports of Santikuna communities adhering to the use of natural dyes, the majority of colorants we identified appear to be synthetic. This observation is not unexpected. Nimoendaju had already reported a significant loss of traditional Tikuna material culture as early as the 1940s, and the replacement of natural dyes with synthetic ones among the Tikuna people has been previously documented. These findings underscore the transformations in Tikuna artistic practices and serve as a reminder of the potential loss of traditional knowledge, emphasizing the urgent need for further scientific investigations. The materials choices and meanings used in Tikuna masks have yet to be systematically explored. However, existing studies clearly illustrate their cultural importance. For instance, the substitution of natural dyes with synthetic ones has been reported to alter the value of the masks in the female initiation ritual. Furthermore, the superposition of the painted human body underneath the mask is critical, as it is exemplified by the myth of the jaguar Torama Ruai. In such a myth, a young man preparing for a celebration party painted his body with watery clay before wearing a jaguar mask. Crucially, he failed to use the colorant asafrua. This omission had dire consequences. He tragically metamorphosed into an actual jaguar. To continue the search for the Tikuna blue, three other main traditional pathways would typically be considered in technical art history and conservation science. First, the researcher obtains a sample of the blue from the Tikuna Maguta community and investigates it in the laboratory. Second, the researcher procures the raw materials and attempts to reproduce the blue in the laboratory for analytical investigation. And third, the researcher investigates degraded masks from museum collections to search for traces of degradation products that could be related to the unknown blue. In all three of these conventional options, the publication of results in scientific journals is the primary aim. These approaches are primarily investigator-driven and academically centered, prioritizing the generation of knowledge for the benefit of researchers and their respective fields. Although some community engagement may occur, indigenous members often participate as subjects or materials providers, meaning their specific needs and priorities are rarely considered in the research design. This contradicts what we have discussed regarding the ethical considerations we have proposed for the scientific investigation of indigenous ceremonial and sacred items. Therefore, to explore more socially responsible and inclusive research practices within our fields, we propose a fourth option. One where researchers and the community work together to both prepare and chemically investigate the Tikuna blue. However, to guarantee mutual benefits, results should be shared or disseminated only after the research group has at least one well-developed plan that directly addresses a specific community need using the scientific results. This approach is not intended to replace existing research methodologies, but rather to complement them, significantly enhancing the social impact of scientific research. Therefore, to continue this specific research, we have combined our art historical and conservation interests with the crucial need from the Ticuna community, the transmission and preservation of their traditional knowledge through intercultural education in Ticuna schools. First, I will present you the chemistry of the Ticuna blue, and second, how its chemistry has been used for the community needs. At least 2 different paints can be obtained from the fruit of naiku. One is purple and the other is blue, prepared by reacting its juice with iron, as it was described by Courtney Moendaju. You can see both paints here with and without chemical reaction. To understand the chemistry involved in the Ticuna blue, we first need to understand how blue is produced in flowers. In plants, anthocyanins are the primary molecules that can produce blue color. To achieve and maintain this color, nature often employs specific chemical strategies. One is inter- and intramolecular copigmentation, and another is complexation with metal ions. For example, the blue color in hydrangea flower is attributed to a complex of aluminum 3+ ions, the anthocyanin delphinidine 3-O-glucoside, and the copigment 5-O-caffeoyquinique. Another example is the petals of Commelina communis, and similar molecular structures but containing iron ions, like in the case of the Ticuna blue, were proposed to Centaurea cyanus, Corydalis ambigua, and Mecanopsis grandis. Naiku refers to plants from the family Zingiberaceae, genus Renealmia LF, and Renealmia alpina Rothbaum is an example, which photos are shown here. A study published by other authors showed that the peel of their fruits is rich in anthocyanins, especially cyanidine 3-O-glucoside and delphinidine 3-O-glucoside. It also has lower amounts of flavonoids and phenolic compounds, in addition to minor amounts of carotenoids. All this information suggests us that the Ticuna people have been producing supramolecular structures similar to those found in nature for the production of blue colors. Specifically, it is suggested that the Ticuna blue is composed of at least iron ions and anthocyanins, resulting chelates like these. The formation of these iron anthocyanin complexes with cyanidine 3-O-glucoside and delphinidine 3-O-glucoside has been investigated by other authors, and it is known that it results in blue compounds. To determine the spectroscopic fingerprint, composition, color properties, and color fastness of the Ticuna blue, we considered mock-ups prepared by members of the Ticuna community and investigated them with colorimetry, fiber optics reflectance spectroscopy, scanning electron microscopy with energy X-ray dispersive X-ray spectroscopy, normal and resonant Raman spectroscopy, FTIR microscopy, and microfading tests. Additionally, computational calculations have helped us to attribute electronic and vibrational transitions. The results will be published and publicly available soon as an open scientific paper already accepted, both in English and Portuguese. To formally name this compound, three associations of Ticuna artisans, AMATU, Associação das Mulheres Indígenas Artesãs, AMIT, Associação das Mulheres Indígenas Ticuna, and AMIPIC, Associação das Mulheres Indígenas de Porto Cordeirinho, met and proposed the name Ticuna Blue, which is the name I am using through this presentation. However, the engagement with the Ticuna community has not been limited to consent, objects preparation, and suggestion of name for the blue. Instead of developing the typical investigator-driven research, where researchers alone define the questions, methods, experiments, and use of results, we have been exploring the community-based participatory research methodological framework, also known as CBPR. CBPR is founded on social justice. It is built on community strengths, promotes mutual learning and reciprocity, ensures results are disseminated to all partners, and considers the sustainability of applied outcomes. While CBPR is well established in fields like healthcare and archaeology, it is still largely unexplored in technical art history and conservation science. Therefore, I am currently working on a manuscript about its principles, possibilities, limitations, and necessary adaptations to help effectively implement it in my fields. Crucially, in CBPR, community engagement begins with formulating the research questions and hypotheses and extends through every stage, including data collection, interpretation, use, and dissemination. Therefore, in our work with the Ticuna people, we are focused on the transmission and preservation of indigenous traditional knowledge and chemistry and intercultural education in local schools from the Ticuna community. Indigenous traditional knowledge is a fundamental part of the identity, existence, and resilience of indigenous peoples, being essential for the well-being of all the humanity. Given the accelerated process of disappearance of this knowledge, several initiatives have been taken for its preservation and transmission. In the context of schools from the Ticuna community in Brazil, progress has been made with the valorization of the native language and the creation of specific courses related with traditional knowledge. However, studies have evidenced that the development of an effective intercultural school, although desired by the community, is still in its early stages. This is particularly true for scientific subjects such as chemistry. This is largely due to the lack of intercultural teaching resources, teachers' training, and scientific research that investigates the interface between indigenous traditional knowledge and Western scientific knowledge related to studies in technical art history and conservation science. In addition, studies have shown that teachers in Ticuna schools have expressed their desire to participate in the production of teaching materials, work in an interdisciplinary manner, and collaborate with elders to transmit traditional knowledge. In this context, we have been developing our art historical research on the Western science involved in the Ticuna paints production. In addition to the Ticuna blue, we are investigating other paints and colors, addressing conservation-related questions, and preparing for research on the meanings and values of these materials and associated techniques. With the results obtained so far, we have collaboratively developed experiments for chemistry intercultural education with teachers from local Ticuna schools and faculty members of a local university campus. To complement it, we are further organizing a collaborative production of paradidactic materials for intercultural education with teachers, artisans, and faculty members from local schools, artisans associations, and university. Finally, we recently organized a workshop on intercultural education in Benjamin Constant in the Brazilian Amazon, focused on knowledge sharing and training, also exploring the results from my research project. This successful workshop took place in August this year through a collaboration between academics and community members from UCLA, the Federal Universities of Amazonas, Delta do Parnaíba, and Roraima, and the indigenous state schools, Professor Gildo Sampaio Megatanuco and Almirante Tamandaré. We also received support from institutions like the Maguta Museum, the Artisans Associations Amatu and Amit, municipal departments of education of Benjamin Constant and Atalaia do Norte, General Organization of the Bilingual Ticuna Peoples, OGPTB, Organization of Cocama Teachers and Benjamin Constant, Union of Indigenous Peoples of the Javari Valley, and the National Indigenous Peoples Foundation from Brazil, FUNAI. The workshop brought together over 200 participants in person and online, featured participation from more than 5 different ethnic groups from the Alto Solimões region in the Amazon, and allowed local teachers to produce materials they can already use in their classrooms across different disciplines, including chemistry. To finish my presentation today, I would like to return to the title. How Chemists Investigate Cultural Heritage, a look at the science and ethics. The way chemists investigate and engage with cultural heritage is highly diverse, reflecting the diversity of cultural heritage itself. Ethical considerations are equally varied and can be especially complex when dealing with indigenous sacred and ceremonial items. Despite this complexity, working with and for communities in this type of research is remarkably academically enriching, socially beneficial, and personally rewarding. In addition to working with the Ticuna community, we are actively expanding our approach to native US American communities. For instance, we currently have a PhD student in my research group working with the Hopi cultural heritage, and we are looking for other national collaborations. This research is a long-term initiative that requires more than just scientific ingenuity. It requires sustained support. So to continue this crucial work and to train the next generation of interdisciplinary scholars, funding is essential. We are actively seeking resources to expand these ethical and collaborative projects and are grateful for the funds we have received from institutions and donors, including and highlighting the UCLA Divisions of Humanities and Social Sciences. I'm also grateful to the Getty, the GRI, and the GCI for all the support and fellowship, the UCLA Clark Library and organizers for the invitation to talk here today. It's a real honor and pleasure. To the members of the Ticuna community for all the support and collaboration, to the museums, institutes, institutions, and individuals who have collaborating with this project, to my research group, and for you all present in person or online. Thank you so much, and I'll be very happy to answer any questions that you may have. Thank you. No. I think we need the microphone for people on YouTube.
Thanks. So thank you very much, Thiago, for a fascinating talk, the way that you brought us from objects in the Clark Library, including Gill's paintings, to then thinking about color with the Amazonian peoples. And somehow this idea of the Ticuna blue is something that was particularly interesting for someone like me who works in the early modern period and thinking about the different ways that blue worked historically. So I have a question about that, but I also just wanted to thank you for bringing us to this this concern that you have for community-based questions and for rethinking the ways that we actually do research, to be thinking not only about the kind of production of research for our own universities and institutions, but also for thinking about the ways that it's a reciprocal relationship with the peoples with which we work. So it was a wonderful journey to follow with you, so thank you. And I'm sure that some of you have questions.
Hi. So I'm the head librarian here, but I really appreciate your talk, and it's actually fairly germane for what's taking place at the Clark itself. So we're actually having a preservation conservation person coming to use the XRF to analyze some of the bookcases that we have in the North and South Book Room, because there's a story that's being told, and I'll kind of get to this question in a second, about what the cabinets are made out of and what that says about the history of the Clark and the kind of pride maybe that William Andrews Clark had in the kind of the copper and bronze that made essentially the fortune that founds this place. So my kind of question to you is, what is the responsibility to someone like yourself in negotiating that kind of balance between the stories we tell about things and then what you actually discover in your analysis?
Yeah, in terms of like, specifically in the context of working with indigenous materials, the main responsibility, I would say, like, is the respect with the community. And like, especially when you are working with like sacred materials, you may have like many materials and processes, like techniques that should not be known by other people, like outside the community. So many museums, they will do specific analysis for the conservation of objects, but they won't share the results. And usually we always like need to ask the permission. But like, the responsibility, I think it goes beyond only like asking the permission, but like also how can we give something back to the community? Like, how can we answer the questions that we want to answer in art history or in conservation, but at the same time that could be useful not only for the museum and for the academia, but like also from the needs from the community in terms of giving back, like that many times we took from the communities.
Of course.
Yeah.
Sorry. So just hypothetically, because I'm very curious about this, like if there is, so do you not then feel like if there's a responsibility for a story that's being told about an object and a discovery that's being made about the object that might suggest otherwise, like, do you have to necessarily grapple with that tension, or is that something that the kind of the guidelines that you're speaking of would help you answer?
You mean in terms of like discovering something with the analysis?
Yeah. So for example, with the Tacuna Blue, it sounded like you were in search of the example of it in some of the analysis of the masks, and you discovered that it wasn't present in these. It was synthetic or a different one. And maybe people assumed that it was present there, and that was the kind of story that they told, that they found this ink and they made it and used it themselves. Yep. So, and your discovery might prove otherwise. So that's what I'm talking about, this tension between maybe the story that you tell and then the discovery that's made.
Yeah, I got it. So this is related specifically with one of the proposals that we're talking about, the ethics. That is, even if the community allows you to do the investigation, it doesn't mean that you are allowed to share the story or the results. Okay, so in this specific case, like everything that we are talking, or like everything that is published already, like the community already gave us consent to publish, and yeah, so the responsibility is just like, and this is one of the challenges that I was talking about, like developing this kind of research, because like when we join a university, the university wants us publishing and they will evaluate us on publications, but like depending on the kind of work that you do, maybe you do analysis and you won't be able to publish the results of the analysis, right? So I'm very grateful like to be working at UCLA, because like UCLA has specific guidelines, including like to evaluate faculty members working with community-based research. So I'm proud to say this of my institution.
Questions?
We just came in here because we like the library, so I don't really know any about this, but I'm reminded of the story where a PhD student went up into the White Mountains and for his research happened, because he wanted to study the tree rings, happened to cut down the oldest tree in the world. And it was like one of the great tragedies to find the story of the tree. So now I'm kind of getting it. The key thing here is, what's the story of the people? And now part of the story we're going to learn is how you get the color. Is it important to reproduce the color, or do we still need to make it? I'm kind of interested in if they could still do it.
That's a great question.
Okay.
Yeah, thank you. Yeah, so this is one of the things that we want for the next steps, because one thing is understand the chemistry that is involved in the production of the paint, of the color, and use these like with the community to produce materials for chemistry. But like this is not intercultural education. So to produce intercultural education materials, we need to understand the cultural context that is like on the surroundings of this chemistry. That it will involve like the values of these materials, the meanings, the importance of of the blue specifically. So these would be like questions that we would be interested in working with the community to understand like when do they use, because I showed you that they use like different plants to produce blue and different materials. So do they use like randomly, or they use like specific materials to produce specific objects for specific representations? So like this kind of information that is like really important for the community also to transmit. But like as researchers, like we have like specific responsibilities as related to your questions in terms specifically of steps that we need to take. So right now, we are just like doing analysis of the chemistry because we like are working with bureaucracies, as I was mentioning, like with legislations for the protection of genetic resources associated with indigenous traditional knowledge. And now we submitted a project for the evaluation in Brazil, in which the goal is to work with the artisans to start like producing these materials. So when we start the production of these materials, we'll probably have like these questions, and then we need to ask other permissions, like to have access to this knowledge, and then ask permission again, like for the publication. So it needs to be very careful and always like working with the community to avoid any kind of harm that we can do. Not yet, hopefully.
Has the environment, the threatening environment for the Amazon, has that diminished the supply of any of the natural resources for making these colors? And if so, will they go synthetic?
That's a beautiful question. Also because it's funny because I'm not at all a specialist in intercultural education. I don't work with, I'm not from the field of education. But like, I have been learning with my colleagues who are specialists in this field. And like to implement this methodology in intercultural education, they need to work with the cultural and environmental calendar. And this includes the resources and access to the resources, and including like how climate change has like changed like the access of these materials, but also like how changes in the society, like sometimes you have like cities coming closer to the communities, and this will also affect like the access to specific plants and specific animals. So the Amazon is like a massive forest. If you haven't been there, it's an amazing place to visit. And there are like many micro environments. So you have like specific plants that will grow in specific areas, but like not in others. So they will have like naturally like different access to plants with climate change and with social, like changes in social dynamics. And not only in the area that I'm working, but like for sure anywhere in the forest.
But if things change, will their designs have to change to accommodate what resources they can?
More or less, yeah. So I'm just repeating what you said for the people online. In terms of like changing the access to materials and changing the design, not necessarily the design, but for sure like replacing materials. So like the way that I was showing the masks that we investigated and the presence of synthetic materials, like it could have like different reasons for the replacement. It could be like something, it could be like maybe like a change in the cultural interpretation of materials. That could be like one of the questions that we could like have in that context. But you naturally see that there in the literature, like there are some people saying that you have like differences in values of masks produced with different, with natural colorants and synthetic colorants. So the change of materials not necessarily related to the access of the natural materials, but also like they are having easier access to synthetic materials. And they have like different properties, the materials. So maybe it's just because they prefer the properties of synthetic materials. So all these questions are things that we want to address with them, but we still don't have authorization to do that.
Thank you so much for your informative talk, Dr. Puglieri. My question is, I guess, so there's an aspect of your research that is very like forward thinking, but then the aspect that is like back, like looking to like conserve things like in museum collections. And just thinking about like how, about NAGPRA, like in the US, and the sort of like the question of should these materials be like even be in collections, and like what then is the ethics of like maintaining their like quote unquote like the sort of like preventing them from degrading. Like some of these materials, like some of these materials, the degradation of them is like part of the cultural significance. And so I wonder like how in this instance, like, because all of this is very hyper-specific, like how in this instance do you navigate that like backward aspect of your research, which is the conservation, is not just like the creation or like figuring out the pigments and stuff.
I'm
Thank
loving
you.
the questions. It's a very complex terrain, especially because like sometimes some objects, they are made and they mean to be destroyed after specific uses. So like they are powerful objects that are in collections. So you have like all these conflicts for sure. And it's not like one answer specifically, because it also depends on the relationship that the institution have with the community. So I know institutions that they have like huge indigenous collections. They have very close and respectful collaboration with the community. So the community can go to the museum, like they call the museum like almost like home, because they have like their ancestors there. They know that like the ancestors, someone is taking like good care of the ancestors, and they can access them anytime that they want. So in many cases, we have like communities that they don't want to take the objects from the museums. In other cases, yes. So it depends a lot. We also have, and this is one of the things that motivated me, like to try to organize and like propose more like in a more objective way the ethical considerations, because not all the museums will request for the researcher to have authorization from the community to take samples or to do the analysis. So it's something that is not only institutional decisions, but also individual decisions that we need to make, right? But yeah, you have like so many alternate possibilities in that area, and it's super discussed. But like I know many cases that they are really happy, and other cases that they are happy also, but like they also want to take care and have the objects with them.
Could I ask you a little bit about the longer history of your research in terms of, I'm meaning historically in terms of time? So I'm thinking about the way that in the 16th century there was so many materials that were exported from Brazil or taken from Brazil to Europe because of the use of like redwood for pigment, for example, for textiles. And I'm just wondering, in the specific research that you've done on the blue, are there ways that in your research you're also finding out something about the longer history of it, you know, for how many generations, for example, a particular blue has been used?
Yeah, it's also a great question. And one of the things that I love about like these different cultures, like from different people, is that they have also, we have like different ways to transmit and preserve knowledge. So we, like in many communities, it will be mostly like oral transmission of knowledge. So it's difficult to have like historical information about when did it start or when it was discovered. And even in the objects, because like sometimes we don't have documents, but we have the objects in collections, right? Yeah. And these masks, we have masks from the 18th century in many museums. And these objects, they mostly don't have colors anymore, because probably, I suppose, they faded, the dyes. So even if the community wants to rescue specific recipes, it's a huge challenge to like do this reverse chemistry or this reverse engineering if all the colorants are faded.
Yeah.
And
I think, sorry, I was actually wondering also, I mean, that answered part of, or it answered the question, but I was also wondering if there's something about what you do as a chemist, that when you're doing testing on some of these materials, if you're actually able to understand something about, like, I don't know, like the half-life of something that would give you some sense of the duration of that chemical?
Yeah, it works for specific, very specific cases. In the case of colorants, I don't think it would work because like you have so many different environmental factors that could degrade. Yeah. So even if you find like specific degradation products, it would be really, really challenging or maybe impossible to like have this aging or the dating of the object.
That's actually a very helpful answer, so thank you for that.
Yeah. Okay.
I think if there's no more questions that we can then move to the object analysis with you. But first, before we do that, round of applause, please, for Thiago.
Thank you so much.
Thank you very much. So in a couple of minutes, if you want to stretch your legs, and then we can come around the table and Thiago will demonstrate the...
Oh, we can't come around the